Every single night, your body gets completely paralyzed. Your brain floods itself with vivid hallucinations and then erases almost all of it before you wake up. Scientists have studied this for decades, and they still can't fully agree on why it happens. In 1862, a chemist named Kekulé had been stuck for months trying to figure out the molecular structure of benzene. One night, exhausted and frustrated, he fell asleep at his desk. In his dream, he saw snakes curling into circles, biting their own tails. He woke up with the answer completely formed. That discovery changed modern chemistry forever. Paul McCartney woke up one morning with an entire melody already playing in his head. He reached for a piano, played it through, and called it Yesterday, one of the most recognized songs ever written, delivered to him while he was unconscious. Your brain didn't stop working while these men slept. It went somewhere else entirely, somewhere without rules, without logic, without limits. So what is actually happening in there every night? And why does your brain need something this strange to function? The real story starts in a laboratory at the University of Chicago in 1952. A researcher named Eugene Aserinsky had an idea his colleagues thought was slightly ridiculous. He wanted to stay up all night watching other people sleep. At the time, the scientific consensus was simple. The brain shuts off during sleep, like a light being switched off. Aserinsky attached electrodes to his volunteers and watched what happened. After a few hours of quiet, deep sleep, something unexpected occurred. The brain suddenly exploded with activity, as electrically alive as someone solving complex equations, and beneath their closed eyelids, their eyes were darting back and forth at high speed. He called it REM, rapid eye movement sleep. Every time he woke a volunteer during this phase, they reported vivid, immersive dreams. The brain wasn't shutting off. It was running its own private cinema. During REM sleep, 4 specific things happen simultaneously inside your skull. Your brainstem sends a chemical signal that locks your major muscles down completely. Paralysis. This is actually protective. It stops you from physically acting out whatever your dreaming mind is experiencing. Your visual cortex activates intensely, producing imagery so sharp and vivid, it can feel more real than actual waking vision. Your prefrontal cortex, the part responsible for logic and judgment, goes nearly silent. This is why riding a giant bird to a coffee shop feels completely reasonable inside a dream. The part of your brain that would question it is essentially offline. And finally, the chemicals required for long-term memory formation drop to minimal levels. Your brain isn't filing this experience away. Within 10 minutes of waking, most of it dissolves. Sleep itself follows a precise cycle of around 90 minutes, repeated 4 to 6 times each night. Early cycles prioritize deep physical recovery, but as morning approaches, REM stages grow longer. The most vivid, strange, emotionally intense dreams almost always arrive between 5 and 6 in the morning, right before the alarm ends everything. If you've ever wondered why your dreams feel so personally revealing, share this with someone who needs to understand what their brain is actually doing at night. For thousands of years before neuroscience existed, humans explained dreams through religion and mythology. Ancient Egyptians built entire temples dedicated to dream interpretation. Priests would decode your dreams as direct messages from gods. Dreaming about death meant long life. Dreaming about flooding rivers meant financial abundance. Then Freud arrived. He proposed that dreams were the unconscious mind revealing forbidden desires through coded symbols. His student Jung expanded it further: dreams as access to universal human archetypes: the hero, the shadow, the hidden self. For decades, the world believed dreams were encrypted messages about who you secretly were. Modern brain imaging changed that conversation completely. Today, neuroscience offers 5 serious theories about why dreams exist. The first suggests dreams are essentially your brain trying to create narrative from random electrical noise. The brainstem fires chaotic signals during REM. Your cortex, unable to tolerate disorder, stitches those signals into a story. The dream isn't meaningful, it's just your brain refusing to accept chaos. The second and most widely supported theory sees dreaming as memory consolidation. Your brain functioning as a librarian, sorting the day's experiences, deciding what to keep and what to discard. Researchers in 2010 found that people who dreamed about a maze they were learning solved it significantly faster afterward. Dreaming wasn't passive rest, it was active practice. The third theory frames nightmares specifically as survival training. Your brain rehearsing dangerous scenarios, being chased, falling, confronting threat so that real danger triggers faster, more accurate responses. Your worst dreams might be your brain's most protective work. The fourth theory shifts the survival framework into social territory. In a modern world where social rejection feels as threatening as physical danger, dreams simulate difficult conversations, embarrassing moments, and emotional conflicts. Practice runs for the social situations your waking self finds most challenging. And the fifth, perhaps the most unexpected theory of all, comes from neuroscientist David Eagleman. He proposed that dreams might exist primarily to protect your vision. The brain is highly competitive internally. Neural regions that go unused get claimed by neighboring regions almost immediately. Experiments showed that blindfolding someone for less than an hour can cause other senses to begin invading the visual cortex. Our ancestors slept in complete darkness for 8 to 10 hours every night. Without intervention, the visual cortex would have been progressively taken over. Eagleman's theory suggests that every 90 minutes, the brain floods the visual system with imagery, not for emotional processing or memory, but simply to signal to surrounding regions. This territory is still occupied. Dreams as a biological security system, protecting your ability to see by making you see things that aren't there. So which theory is correct? Probably all of them. Evolution doesn't waste mechanisms. What may have begun as simple visual cortex protection became something the brain recruited for memory, emotional processing, creative problem solving, and social rehearsal simultaneously. We have photographed black holes, we have decoded the human genome, we have built machines that think, and we still cannot fully agree on why the brain runs its own private cinema every single night. That gap between everything we know and this one remaining mystery might be the most fascinating thing about being human. Tonight, when your eyes close and your body goes still, something extraordinary is beginning. Something science has studied for decades and still hasn't completely solved. You're about to enter the strangest, most personal, most privately brilliant theater in existence. Subscribe because there are entire universes inside human psychology we haven't explored yet, and every single one of them will change how you understand yourself.